look at the one reaction which you got to know is the cleavage of esters in acid. So what happens here is that's the one reaction. Ethers are very stable, so they don't react much. So they only react to one thing, which is your acid. And the acid would be not even HCl, no, it will be HBr and HI. These are the guys that can make ethers react. So what are you going to have? You are going to have your ether. The general thing that happens is you have your ether R, then bonded to OR, then here we have the R prime. Then it's going to meet, of course, the HX. Remember, this is HBr or HI. Then what's going to happen is it's going to break. So what's going to break is, and what you're going to have is H goes, and then the R will take the RX. So you have ROH plus R prime with the X. And that's what happens. Now, what I want you to know is the guy that remains with O is always the guy which is higher. So if there is secondary alcohol, he's going to be the one that remains, the secondary carbon, he's going to be the one that remains with the O, whilst the primary goes and bonds with the X. Okay? And this happens all the time unless you meet tertiary. So let me show you. If I have something like this, if I'm going to have a, let me put it like C, then here we have a CH2H3, and then here we have a CH3 again, and we have bonded to an O, then here we have a CH3. Now, this is, we could even have this CH2 bonded to a CH3, okay? So who is better? Here, this one is a primary, right, carbon. Here, this is a secondary carbon because he's bonded to two other carbons. So he is the one, the secondary carbon will remain with the O, so it will break here. And what you're going to have, if it meets with HX, is you are going to have C, here it's still CH3, okay? I'm sorry, actually, this was supposed to be, yes, CH3, but I'll put it like up here, say CH3, then CH3, then an H here, okay? So that makes sense. So in here, we would have it still as a CH3, and in here, we still have our CH3, here we have our H, but now this becomes OH, okay? Plus, here is where you'll get the X, so it becomes CH2X, and then CH3. This becomes what happens. The X goes to the lesser one. And this happens even when you have a ring. Let's say we have a ring. Let's put a ring now, like this. Okay. Did I do it well? Let me do it again. One more time. I'll do it like this. 2, 3, then 4, 5, then 6. All right. Now it's proper. Then I'll have it like this, then like this, then like that. Okay. Here I skip, right? So that's how you just do it. You skip a step, then you put another one. So now here, let's say I have an ether, which is like this. And it meets HX. What's going to happen here? We know that we can't break it. We can't break it here. No, you can't. You got to leave the bigger guy with the oxygen. So he's going to remain with the oxygen. So we break it right here, right? So what's going to happen is we'll end up having it like this. This is now OH, right? And then this smaller one now becomes a CH3, then X, okay? So that's just what happens. But this all changes for one guy, when you meet one guy, and that's going to be the tertiary. Tertiary doesn't do that. So let me show you. If you have a carbon which is bonded to a CH3, here a CH3, here a CH3, and then he is bonded to an O, then here we have a CH3. Now, when it's like this, guess what happens if we meet an HX? Tertiary, we know he is the bigger one. He's supposed to remain with the O, okay? The O is supposed to remain with this guy, but for tertiary, the O actually goes. Go away. He actually chases away. Only tertiary. And what you end up having is CH3, only tertiary, please. CH3, and then CH3, and then here, that's where the X will come. And then here you now get a CH3OH. Wow. So the smaller the smaller guy becomes the alcohol for tertiary. That's what you must know. And you're done with ethers and you're ready to go. Remember, they only react with HX, and that's where they split. That's it for ethers, and you're done. Bye.